Hello everyone, welcome to the 5th lecture in the Pro Lego Pro Engineer / Creative Elements Pro video tutorial series. So in our last lecture we went over creating a 2x3 Lego brick using the shell and rib commands. So in this lecture we'll go over creating a Lego Technic cam using datum curves. So of course start out by creating a new part here. So let's call this cam, C-A-M, and K. So, if you recall from last time, we also created a file from our relations. So we typed up a bunch of relations that have, say, the Lego unit and the sort of stud unit defined within them. So we'll go ahead and import that now. So go to Tool, Relations, and then for File, Import Relations, go to where they're stored here. So we'll have Lego Relations.txt, and File Open. Now you see everything we had defined last time is now we have in our Relations Manager here. And we're going to add to this one new relation. So essentially in the new set of parts, i.e. the new NXT set. Of course, I think these were around earlier as well. You have studless bricks, meaning that you have these sort of beams that don't have studs on them. They have holes in the center, or like the holes going through, but they're not exactly the same as the bricks, and they're actually not the same size either. So we're actually going to add in that unit as well. So we have basically our beam depth, or I guess beam height, say beam, it's more of a diameter that we're going to use, so say beam diameter, so say BD equals, and it's 0.744, that's in centimeters. So we'll go to Export Relations here, we'll actually save over this. So we're adding this to the Lego relation. So if we save here and overwrite that, we're adding this last part in here. So let's click OK, and then we'll start by creating our sketch. Actually, we're creating a curve first. We can also create the curve in the sketch, but it defaults to being outside of it. So say from equation here, click Done. We'll select the coordinate system here, and then we'll click Cartesian. Okay, so as you can read on the top of this file, we have a dependent variable t, which ranges from 0 to 1, and some kind of step size for each value of t. But that's used to generate the points for the, I guess the trajectory for the datum curve over the x, y, and z axes, so axes of the coordinate system that we have. So let's quickly see how this works. So we'll copy this, get rid of these comments here. So we'll click Control S to save, or just go to File, Save, and then exit out, and then Preview. So now you see we have a circle here that is, I think the file said 4 units or 4 centimeters in radius, and it ranges across the entire 0 to 360 degree range. So I mean, that's kind of, we can make that in Sketcher, so it's not that impressive, but we change this because it's equals t. So now z, instead of being 0, instead of being on the xy plane, it's now going to project out of the xy plane onto the axis. So if we save this, let's Control S, and then close, and then preview again, we'll see now, instead of having just a 2D circle, we have a 3D helix. So the radius is still 4 centimeters, but now it's projected 1 centimeter from where t equals 0 to where t equals 1 on the z-axis. So Z is increasing linearly in this case. So this is actually a pretty good way to draw, say 3D shapes. If you wanted to draw the trajectory for a spring, you can do so by using these datum curves. So it's also useful to make sketches that are based off of an equation that would otherwise be hard to draw just using circles or even trying to use splines. So go back to equation, click define. So now we're going to draw our cam. So get rid of that. We'll say x equals, so I can say LU, our Lego unit, times the cosine sine of t times 180. Meaning that we'll have, if we're drawing a circle, we would have half a circle that was basically ranged on the x-axis from -1 to +1 Lego units. So for a y unit, then we'll have, here's kind of complex. Say LU plus our BD value, our beam diameter, beam depth value, divided by 2. So we're averaging those two values times sine of t times 180. And actually, we're going to make sure that this is on the right side, or the negative side of the y-axis. I guess negative side of the x-axis would be in the negative y range. And then z would equal 0. So again, we'll save, click exit, and then preview. So zoom in a little bit here. So now we have the profile of at least the one side of our cam. So it's more like if you've ever seen before, it's like an egg shape. So this is sort of the bottom of the egg, and again, it's not actually a circle that we drew. It's more of an ellipse, and that so the dimension here from the center to the outside point is 1 Lego unit in the x-axis, but in the y-axis it's the average of 1 Lego unit and the beam diameter unit. So it's about 0.77 or so. So here, let's click OK. Control D. Okay, so now we have our bottom trajectory defined. What's kind of bad about this is that you can't define a piecewise function, so we can't define more than one equation with one datum curve. So we will create another curve from equation, select our coordinate axis, and select Cartesian. Do the same thing here. So our x is essentially the same. It's LU times cosine of t times 180. And of course, if you're also familiar with math, you know that cosine is an even function. So what we could have done is change the range of t to be negative, which would also be the same thing as changing the negative sign to positive sign and then negative t. But because in the case of cosine, because it's an even function, cosine of negative t would equal to cosine of positive t. So therefore, we don't actually have to specify what the sign of t would be in this case. But just in case anyone was confused. So we have our x is the same from last time. So y is now, this would be 3 times LU plus BD divided by 2. So it's basically 3. You have 3 halves LU plus 1 half BD. So if you remember in the last equation we had 1 half LU plus 1 half BD, so that evaluated 2. And our cam is actually it's not actually 3 Lego units long. It's the same length as a 3 unit long Lego stubless beam, which actually, if you remember, our value for the beam diameter is a different value than our standard Lego unit. So that's why it's kind of good to note this. So we have sine of t times 180, and z is equal to 0. So we'll save this, and then press the check mark or the close button, and then preview. So rotate this around a little bit. So that's pretty much the two equations that describe the shape of the cam. Again, it's more of an egg shape, but and we could have also done this using a sketch. But as I said, sometimes it's easier to define sketches like this using equations, just because we know we can determine what the trajectory would be, or what the trajectory of the lines would be, more easily than having to use dimensions. So with that, we'll click OK. Control D. Okay, so now this is our shape that we want. So now we'll create a sketch. We'll click Sketch. Click on top plane. Sketch again. And we'll use the Use tool right here. So let's click on both of these lines, both of those equations, to create sketch lines. We can't actually extrude the datum planes or the datum curves by themselves. We need to have actually a sketch that's driving the extrusion. So what that means is that we have to create a sketch from the datum lines that we've done, which are basically the same thing. I mean, if we change the datum curves, then the sketch will change as well. But we just need to be careful when doing that, because these 2 points here, or this curve and this curve, need to be coincident at the endpoints. So that, and we can also check just to make sure everything is closed up by pressing the I-beam button here, the shaded closed loop button. So shaded means closed, so we'll click Done, and then if we have this highlighted, we'll click the extrude icon. So this extrusion now is LU divided by 2. So it's half of a Lego unit. And just to make this sort of mirrored with respect to the top axis, we'll click the extrude on both sides button. So now we have our sketch, or our sketch is still defined in the center, but it's being extruded in both directions by LU divided by 2. So each one, so from this point to this, or from this plane to this plane, is LU divided by 4. So click check, Control D again. So now we're done with defining the shape of the cam. So what we're going to do next is create the holes that are used for the beams or the axles to insert. So if we're familiar with the Lego axles, let's click Sketch here. If we're familiar with Lego axles, we know that they're not circular, but they're cross-shaped. So that's used to sort of mesh with the parts to allow them to rotate. So wheels rotate the same way. They mesh with the axles, and they're driven by gears and motors. So start out just by drawing our, say, the profile of the axle. So this is the same as the stud diameter. So say SDIA, enter. So that's pretty much the size that we're looking for. But of course it's also like I said, it's not just a circle, it's a cross. So we'll draw now just 4 lines in the center here. You can see they're all, so we have vertical lines 2, 4, we have horizontal lines now that we're creating. What we want to do is, so the axle, the width of one of the crosses, or one of the sort of parts of the axle, is 0.175 centimeters. So it's also the same over here. 0.175, enter. and also centered with respect to the X and Y axes here. So what we'll do is we'll go to, say we'll use the equivalent, or the equal tool here. So we'll say this equals this, and this equals, okay, so those should all be equal then. You can either make these two equal, or if you make three of them equal, then the fourth one by default will also be equal. So now what we want to do now is we use this as a template to draw the shape that we'll use to extrude or cut. So we don't actually want to do anything more with this. So what we'll do is we'll highlight everything here. Highlight this, and we'll go to should be Edit, and then Toggle Construction, or Control G. So now what we have is, so the construction lines aren't used in any kind of, they're not sketch features that can be manipulated. So we can't, we can manipulate them in the sketch, but we can't extrude them. So right now the sketch actually doesn't have anything that we're actually going to use to extrude any kind of features. But we can create another sketch here and draw lines from these points. Doesn't matter if they're actually. So we'll draw these sets of lines here. They can touch, or they don't have to touch, but they just need to be drawn. And then we'll go to the corner tool here. So now what this does is we have two lines here that they're not intersecting. We click one, and click the other using the corner tool. We can create a corner that is these 2 points are coincident now. So the same thing here. So we'll click on basically the size that we want to create the corner from. So the inside corners here. We'll have from that our corner set up. And we can also use this set of tools here. This is actually the trim tool, the delete segment tool. We can click on segments that we want to get rid of, namely the ones on the outside. So now we have our cross shape axle that we want to extrude. And before we leave, these also have a sort of a fillet slash, I guess, round on the inside corners. So we'll insert that using the circular tool. And again, these don't really have to be precise for now. But you can see I'm clicking on each corner here and creating the feature. Now, our radius is, our diameter, if you measure from one of the axles, is 0.1. So our radius is then 0.05. Click Enter. And then we'll also use the equal tool. So set these all as the same radius. So you see we have tangent, radius 1, tangent, radius 1. So our radius 1 here. And with that, so before we exit as well, we want to move this a little bit. So right now we're centered with respect to the XY axis, which is easier for us right now just to create this feature, but we want to actually offset this from the axis. This will be easier when we make when we have to pattern this feature. Let's do point on entity, delete. We'll set this as, should be, I think, LU divided by 2. Enter. Enter. Okay, so that's in the position that we want it to be. So we can go ahead and click OK, and then it'll be done. So we'll click the check mark. So now we're back to extrude. Face the direction. Click the remove material icon, and we will select. So here's a new one. This is the extrude to intersect with all surfaces, meaning that this is basically a way to cut through all surfaces. So if we have a hole that needs to go all the way through, instead of just specifying a blind depth, or instead of actually having to choose a surface. Just click this here. You can see we're now going through, basically going past all the surfaces in the model. So that's what we want. The check mark. So now we have our axle hole here. As I said, the reason why we offset this from the center is that we're going to pattern this. So click on our extrusion here, go to pattern, go to direction, and click on the front datum plane. So now we're extruding, we are patterning every LU divided by 2 units. So hit enter twice. And we're going to have 5 in total. So now, as I said in a previous lecture, these nodes can be turned on or off. Basically, if they're black, it means that they're not being suppressed, they're being shown in the feature. But if they're clicked to white, then they're not being shown. So if anyone's also ever seen the cam, which is kind of a weird setup for this, it's you have 3 axle inserts, and then you skip a space, and then you have 1 axle insert. But it is 3 beam units long, or I guess the axles are spaced. This should be 1 Lego unit and then 2 Lego units. So there's 1 in the center here, so it's 1.5, or it's half of a unit and then 1 unit. So just to explain what we're actually doing here. So we'll click the check mark. So that's what we should have now for our shape. So we are almost done with this. We just need to create sort of the inner profile, meaning that we need to create a sketch here. What we'll do is, so we'll go back to the Use tool, go to the Offset tool, go to Loop. Let's see if this will work. So we have negative 0.133. So that number comes from, basically, if you zoom in, you can see that this line is coincident with the diameter, or the side of this surface here. So I think when I measured this, that's what the unit was in the part. So I'll go back, create another loop around the surface. Put here a single, and then negative 0.133. So these should still be coincident. Close this. Okay, so they're not. So I just clicked on the highlight open ends tool. If you're ever confused, if you create a shape that you want to extrude and you have an issue where you can't see if it's closed or not, i.e. if you click this button and it doesn't show it, then it might not be closed, and therefore you need to use the highlight open ends tool. So we fix that by on the coincident tool here. Let's see if this works. Do these here. Let's try this again. Okay. So I'm assuming this is facing out. Well, 0.133. Okay, so now that's. I'm not sure why I wasn't doing it before. But now we have our shape that we're going to use for our extruding cut. Let's click OK, close. What we want to do now is just create a few circles here. These have no real radius right now. See, so the R means that they're the same radius. We're going to, okay, so we haven't done so already, turn on the datum axes, or the axis datums. Okay, so apparently it doesn't have them. Alright, here's what we'll do. So import these here. So these surfaces now, we have our mark. We'll use the constraint tool to constrain them. Okay, so now we have these two circles drawn. The radius should be BD. So now, let's draw two lines intersecting. So these are vertical lines, they're tangent to this circle. And they're at basically the apex of the circle, so at the very top and very bottom. We're going to use our delete segment tool. Delete those there. And lastly, we have a sort of a bridge connecting these two parts, or these two circles. These are 0.3 units apart, and they're also the same length, meaning that we'll have a centered part, or we'll have these two lines being centered with respect to the x-axis. Okay, so now we can just use the trim tool again. So we have the inner profile that we're going to cut away. Should be highlighted here. So again, we offset this by 0.133 centimeters. The circles at this point and this point are 1 beam diameter in length, or in radius. Sorry, beam diameter in diameter. And then we have these two lines are 0.3 centimeters apart and the same length. Click check, and then we'll go to extrude, extrude inward, and cut. So I'm going to set our proper cutting depth. So in the parts in the CMU library, for the beams, the inner sort of beam width is 0.2065 centimeters. So we can find that, and basically we'll create our part of that length, or our width, by typing in, should be LU divided by 2 minus 0.2065, and then quantity divided by 2. So we have our set depth that or our set width that we want. We have the total width from basically from the entire part, and then because we're only going halfway, we're dividing by 2. So we can click check mark. Oops. Right here, what's supposed to happen? It wasn't saved, so let's say LU divided by 2 minus 0.2065 divided by 2, enter, enter. Okay, and then we'll click the check mark. So now, at least on one side, we have the shape that we want. We can easily create that on the other side by actually clicking the mirror tool. So here it is. So mirroring with respect to top datum plane. And click check. So now we have our same feature on the other side. Go closely again, so we have our cam is the right length, it's the right shape, and it has all the right features that we want. So this thing we'll do, go ahead and save. So Control S. I'll save it right in the directory that we want it to have. So click OK, and basically we're done now. So just to recap, we went over how to create datum lines or datum curves using the datum curve tool. We learned how to use construction lines and sketches. We learned how to use the offset tool and also the use tool. I guess we've used it both in the past, but kind of went into that more in depth. And we learned how to use the mirror tool. So that's been it for today's lecture. Again, thanks for watching, and I'll see you guys later.